All right, so to quickly cover the imaginary numbers, we're going to go through and look at just a few things. We've got the square root of 49, which you should recognize is 7. Why? Because 7 times itself is 49. Okay. What about the square root of 36? That is 6, because 6 times itself is 36. So what about the square root of negative 25? Well, if we say that that's negative 5, that's not true, because negative 5 times itself is positive 25. And if we say it's positive 5, then that's not true either, because positive 5 times itself is not negative 25. So what we're going to do is use something that we already know and kind of work with this thing and get it down. So if I rewrite negative 25 as 25 times negative 1, then what I can use is properties of radicals, and I can give each factor its own radical. Okay, so now I do know what the square root of 25 is. It's 5, and then I use I to represent an imaginary number. So I is representing an imaginary number. I is not a variable. Its value is not going to change. It's a symbol that tells me that I'm actually representing the square root of negative 1. Okay. So that being said, why do you have to do this? So let's look at a parabola, which we may not have explored enough yet. But if I graph a quadratic, or if I graph an x squared, it makes a parabolic shape. Okay, so what are my options? I could graph this one, and in this case, I have 2 solutions. So your solutions are going to be where it hits the x-axis. Okay, so my exponent is 2. I have 2 solutions. Well, what about if I graph this one? Okay, so here's a different parabola. Well, now I've got a single solution. So it hits the x-axis 1 time, so I would find 1 solution. Well, now there's going to be a third case, and that third case, I don't have another cool pen color, is going to be, we'll use blue, okay? If my parabola is hovering below or hovering above the x-axis, that means I'm not going to have any solutions. At least I'm not going to have any real solutions, okay? So I can make a parabola and I can do a drawing of it, and I can see 2 solutions, 1 solution, or no solutions. I can't say my solution is 0. I have to say that there are no solutions that are real. So these ones, these highlighter blue ones, are going to have imaginary solutions. So that's one of the reasons that we have imaginary numbers, or that we deal with them, is so that when I'm working through algebraically and I'm working through an equation, if I come into something where I end up slammed with a negative under a radical, then all of a sudden it should make sense to me, oh, okay, the picture of that will not hit the x-axis. So that's the way that we align those topics. When you are reducing your exponents, one of the things when we're dealing with imaginary numbers we just covered, and one of those is no negatives under radicals. Or I'm going to say under even roots, like a square root or a 4th root or a 6th root, so on, so on, so on. So no negatives under even roots. So that's how I'm going to handle this one, is as soon as I see that negative, I'm going to recognize that I'm dealing with an imaginary number. The next thing that I want to notice is I don't want to have any, excuse me, no exponents on I other than 1. Other than 1. So I don't want to have any exponents on my imaginary number other than 1. So as we go through and generate this, I am going to show you, and it's going to be a little bit repetitive, but I is the same thing as the square root of negative 1. So I'm going to say I to the first. is the same thing as the square root of negative 1, which I'm too lazy to write that, so I'm just going to rewrite that as I. Notice I'm writing it without the exponent this time. So what about I squared? So I squared is going to be the same thing as negative 1 times negative 1 underneath a radical. Okay, now be careful because you're in imaginary number world. So we don't do the multiplication. We do what the symbol says. And the symbol says that the square root of something is anything times itself will be the square root. So I actually have negative 1 times itself is the square root of this. So I squared becomes, holy cow, negative 1. Sorry. I squared becomes negative 1. So don't simplify this. You're in radical world, so we have to do the definition of the square root first. So what is the square root of something? Something times itself. So that negative 1 is going to pop out. So what about I to the third? Well, we're going to use something that we know. So I'm going to use I squared times I. Well, I know that I squared is negative 1 times I. I am not under a radical. So a negative times a positive is going to be a negative. So this is going to be negative I. Okay. So I to the first is I squared is negative 1, I to the third is negative I. And now I've got I to the fourth. Use something that we know. So let's do I squared times I squared. I am not under a radical, so I can go ahead and say a negative 1 times a negative 1 is a positive 1. Once I hit I to the fifth, it's going to start repeating. So I can say I to the fourth times I. Well, I to the fourth is the same thing as 1. Okay, so I to the sixth is going to be I to the fourth times I squared, which is 1 times I squared. I to the seventh is going to be I to the fourth times I to the third. So we get in this repetition thing. So what if I have I to the 162nd? Okay, what that's going to look like is get rid of all groups of 4. Get rid of all groups of 4. So I'm going to take 162 and divide it by 4. So 4 goes into 16 4 times, which gives me a remainder of 2. My remainder is what I'm interested in. And that's going to tell me what level I am in these first 4. So if my remainder is 2, okay, that means that I'm on the second level here, which means I to the 162nd is the same thing as I squared, which is negative 1. Okay, so that's a quick rundown on imaginary numbers. So let me know, as usual, if you have any comments, questions, or concerns.